So let's welcome Graeme from Dasbury, and he's going to talk about DIALS.
Okay, I used to be at Dasbury. I think my employer.
Oh, sorry. Diamond, sorry. See how old I am.
Yes, I am indeed a veteran of Diamond as well. Dasbury and Diamond and so on. Okay, so I talk very fast. If I'm going too fast, do this, okay? Because I appreciate not everybody in the room has their first language as English. Yes, thank you, Nick. Okay. Right, so because I could well run out of time, the first thing I'd like to do is acknowledge the organizations and the people who have contributed to this work. So everybody in the room knows that developing software costs money because we like to do things like eat, live somewhere, have children. These are all expensive. So yes, we have been very lucky. Oh, hey, that's so we've been very lucky over the years. We get lots of money from various organizations and very kind grant awards and so forth. Wait, the laser pointer advances the slides as well. Okay, good. And then also over the years, certainly in the world of single crystal X-ray diffraction, authors of software have been very kind in writing detailed papers on how their software works. And so that means that we start from a very fertile ground rather than an empty field. Okay, over the years also many people have contributed to the DIALS software. Here's a list which is probably out of date because people keep on adding software and so forth. So you can go and have a look at the GitHub and see who has contributed. Okay, so this is of interest to people who work in single crystal X-ray diffraction. I will not be offended if you have a 20-minute nap if you are not interested in single crystal X-ray diffraction. However, if you are interested in pixel array detectors and you have to look after them and curate them and look for dead pixels, I will occasionally mention things that may be useful to you. So keep half an ear. Okay, so what am I talking about here? So the idea of basically with DIALS is we wanted to write some new software for doing single crystal X-ray diffraction data processing. We didn't want to write a black box like XDS, like MOSFilm and so forth, because basically everybody who was involved at the beginning of DIALS was frustrated by black boxes. So what we wanted was actually put together some software which would allow everybody to get their data processing done, but also people like the people in this room to be able to use and abuse the software in entertaining ways. Or if you're a scientist and you want to develop some new algorithms, or you've got a postdoc who's looking bored and you want to make it do something, you can send them off in their merry way and they can contribute to the software. We started it off with CCTVX, and it's a hodgepodge of C++ and Python. And I think it's fair to say it is not a gold standard in how you develop good quality software, but it is very useful, and there's an awful lot of useful tools in there that may be useful. We did take a lot of inspiration from Star Trek as well, which was actually some very nicely designed software from the prehistory of time, and I realize now that most of the people in the room are younger than Star Trek. So I shall move on. Okay, so the general capabilities of DIALS are that this is for doing single crystal X-ray diffraction data processing with a minimum of assumptions. The minimal assumptions are along the lines of your detectors are flat. You can have lots of them, but they are not actually curved or spherical or whatever. It is kind of optimized for pixel array detectors, but it really is only useful for single crystal diffraction, where you can have lots of single crystals, but we don't do powder, we don't do small angle scattering, we don't do all the stuff that was being talked about earlier with the easy diffraction stuff. So, as an overview, I was going to start off talking about the automated data processing that is maybe useful if you want to put tools there in place, automated processing for your users. There are some command line scripts that you can do to make your own automated tools if you feel so inclined. There's a few very useful sort of more advanced tools, and ultimately there is Python API. There's also C++ in there as well if you feel really keen, but at that point you'd be asking us not to you. Okay, so the automatic processing is really the same as all of the other automatic processing. In our case, it is with ZIA2, but basically it takes diffraction pictures, we can run DIALS or XDS, and we get MTLA files. For those of you who do not know what NTZ files are, it's just basically the reflection intensities and their uncertainties and then their indices. It does all the decision making on behalf of your users. So you basically put in images and you take out the resulting data. And a Diamond is one of the workhorses for doing all of the automated processing in MX and small molecule single crystal diffraction. In the general sense, the way you run it is ZIA2 and here's some data. So you can be less or more specific on how you say, here are the data. It's either a directory full of data, or you can point to images, or you can point to subsets of images, or you can point to lots of different images, and so on and so forth. But generally speaking, you give it the data and it gets on with it. There are some options that may be useful. So if you have a multi-axis goniometer, you can do things like indexing multiple runs at the same time, which can be particularly useful if you're doing, I don't know, like absolute structure work and you do crazy stuff like measuring with the detector here, then here, then here, and then back here. Obviously, most people don't do that, but actually at Diamond on I-19 we do. There are some other options that you can tweak as well, but for the most part, this is stuff where it's there, it's automated, there is some documentation. So if you want to know about this, just remember there's this ZIA2 thing, there's documentation. Okay. There are some other ZIA2 tools that I will talk about very briefly as well. So there's one called Screen19, which we developed at Diamond to solve the problem of chemical crystallographers using a Pilatus detector. So for those of you who don't know, small molecule crystals occasionally diffract exceedingly well. If you put one of them on an undulated beamline, you get very strong spots. Pilatus detectors do not like strong spots. So what we found is they were used to using CCDs when they were very, very weak, weak